let's talk chemistry. The Osborne Illustrated Dictionary of Chemistry, Organic, Inorganic, and Environmental Chemistry. This goes ahead, and we're gonna have to start talking about it. The periodic table, for one. The periodic table is a pretty interesting thing, because I've already told you guys about the elements and how they're grouped together. Well, this is where we actually get to use them. Now, there are lots of things about inorganic chemistry, but this chapter, apparently in this book, actually just talks about the groups, like group 1, 2, 3, 4, 5, 6, 7, 8 transition metals, and the iron, copper, and zincs, which are parts of the transition metals. And let's just keep going ahead. Now, let's start off with the transition metals. Now, transition metals are the ones that you see mostly in your daily life, and it's the one that industrial workers work with the most, because they're mainly the ones like the metals, the irons, the zincs, the coppers, the leads, all those kinds of things are transition metals. And then we actually find out these transition metals are really good conductors. They're really good at conducting electricity, which is really good for household appliances. But then they realize some of them are too good, and that if you even run a current of electricity through it, it'll conduct it too good and too fastly that it'll get hot and probably explode, because it's too good at conducting electricity. And so they needed some different kinds of conductors, and this is where semiconductors come in. But semiconductors, you might sound, hey, that sounds weak. Well, sometimes a weaker version of a conductor is the kind you need, because these guns won't melt, and these ones definitely will not explode even if you pass a very, very big current through it, because it can't pass too much current through it while like too fast in a short amount of time. No, that's not possible. Now let's go to alkali metals. Now, alkali metals is a group 1, and it also includes hydrogen. And the alkali metals are just the things that you see in fireworks, and it's like sodium, lithium, those kind of things. You even have radium and all those kinds of things too. But the thing is, these alkali metals are actually useful because they're the most reactive. They're like, if the periodic table was a feudal system, then the group 1 elements would be like the peasants. They're all like, we'll do anything to gain electrons. And imagine electrons is money too. And the group 8 electrons, the noble gases, they're not gas that comes out of royal families, by the way. Those are the ones that are like, man, we don't react to anything unless we're ionized. And they're like, hey, we don't need any of this. Blah, blah, blah. Go away. And they have enough money. And the lower you go, the more richer they are, and which makes them less reactive. Unless you're like group 8, where the you're the noble gases, and and like if you okay, let me tell you, if you go left of the periodic table, then the reactivity will go from top to bottom, top being least reactive and to bottom being the most reactive. And if you go from the middle to the right, it'll be the reverse, because technically these are going to get less reactive too, because they each have more electrons on them. Let me explain. So it goes from top to bottom, is least reactive to most reactive to the least reactive, because they've got more electrons and they don't need that many electrons too. Also, each group needs the same amount of electrons to fill their shells, which makes them have similar properties, which is why lithium and sodium can be used in fireworks, but they give off different colors too. Then we have alkaline metals. These are basically called the alkaline earth metals. These are the ones you probably find in your earth. Now, one of them, beryllium, is actually in your fire alarm. So you can just go ahead, dismantle a lot of fire alarms, and you get a good brick of beryllium. But you'll probably get a lot of government watch lists, though, in the process. Then I really explained the transition metals. So let's go ahead to group 3 elements now. Group 3 elements are just the boron group, but we call it the boron group because boron is the first group 3 element, and this is the kind I actually like the most. These have lots of properties too. These are similar in properties too. They each need the same amount of electrons to fill their outer shells, but they don't really need that much. They also have the same reactivity. Well, similar reactivities anyways. Group 4 elements, which is like the carbon elements, these are the elements for life. Well, at least the first element is. The rest we're not really sure. And these have similar reaction types. And group 6, it's the nitrogen group. And these are basically good for nitrogen stuff. It's also good. Apparently, some of them are good for fertilizer, nitrogen. And others are just good for, well, the first element that's called livermorium. And we have no photo of livermore. Then we have the Group 7 elements, which is the halogens. Yay! These are all gases, or liquids and all those kinds of things. But that works, and it works too. Then we have Group 8 elements, the noble gases, and I've already explained to you, top to bottom, it's most reactive to least reactive at the bottom. And so, who's the king of them all? Currently, it's organism with 118 protons, and if it's not an ion, 118 electrons. Also, we haven't been able to create organism, so we've only been able to create organism long enough for us to observe it. As soon as we finish observing, which is in like a few seconds, it disappears. Sometimes it's just a few microseconds. And yeah, that's it. Next, we're going to have to talk about inorganic. We're going to have to talk about organic chemistry. Now, the only reason why I didn't actually talk much about the carbon molecules here, I didn't talk about particles at all, but in organic chemistry, it talked about all molecules except for carbon-based molecules, because that's for organic chemistry. Carbon is the element of life, and all carbon elements are usually somewhat related to life, except for diamonds and graphites and those kinds of things, but hey, we don't care about those. Organic chemistry goes ahead. We actually have to talk about alkalis, acids, and all those things. Alkynes, and alkenes. Yeah, I'm not gonna get into these, but homoglobius, they're pretty useful for this. You can study this organic chemistry to go ahead and pair it off with biology. And if you know all this stuff, then you can go ahead and be a biologist or a chemist. Hey, that's 2 fields for you. Next, you're going to have, also we can talk about this with polymers and plastics. Polymers and plastics, believe it or not, they're actually made of plants. They're made of dead plants, by the way. Some of them are made of oil that just turned to crude oil that's turned into plastics instead of like oil that we can actually use. And yeah, this is also helpful to treating wounds with chemistry. And if you want to learn some about this, then go to bed like a science guy and those kinds of things. And finally, we're going to talk about environmental chemistry. This one is mainly about the environment, the effects of it, and the effects of global warming. Now, water is a useful environmental compound because it's the most essential liquid, the most consumed liquid in the world. Then we have to talk about air and burning. Now, air is the things that we breathe, and the things that we breathe out. It's also, we vibrate the air whenever we talk, which is the reason why I can talk right now and you can hear me speak. Because every time you turn on that video, the speakers inside actually turn my voices into electrical pulse, convert it into electrical pulse, and then your speakerphones convert the YouTube electrical pulses into sound, which the speaker goes out and vibrates the air into, which is really useful unless YouTube is lagging. Likes. Then we have to talk about pollution. Pollution is the most harmful thing that we've created so far. Sure, war is actually the most harmful thing, but pollution affects everyone. War only affects some people, not everyone. But global warming and pollution, it affects everyone, people. Once you pump stuff into the air, everyone breathes it because the air is shared. No one owns air except there. Also, there's this thing called the airspace. Airspace moves, or inside airspace it moves from one airspace to another. You can't claim air. It'll move because air is unconscious, and you can't control air. I mean, you can, but you can't control all of air. Then that means you'll be like, hey, you guys, stay here. You literally have to create boundaries, and then you basically create yourself into a vacuum, and then, well, you would have no circulation of air. Yikes, and that's a bad thing. But pollution itself is bad because usually carbon dioxide and other greenhouse gases are pumped into the air naturally, and after all these years, it's just all that carbon dioxide out there is just enough to actually heat our planet, just enough to be like at 2 degrees, and good 2 degrees too, because now we can live here, and it's gonna stay that way for a while, and then we start pumping greenhouse gases, more carbon dioxide, more other greenhouse gases in there, and when we pumped it in, that shouldn't have happened naturally for like eons. Or at least billions of years. And then suddenly, we realized, hey, maybe we should stop. And they're like, no, this is the cheapest way to get fuel. It's also the best way to get rich. And yeah, it's like trying to change the tire of a bus while the bus is moving at full speed, but it has to be done. It might be dangerous, but it has to be done. And that's pretty much it for this video. I really hope you guys enjoyed this episode. I hope to see you guys soon in the next video. And until then, shine out. Peace. Boom.